All right, hey y'all. So after a weekend of not looking at this practice test, I am back. So this is part 3 of the Unit 3 practice test, and we'll just kind of jump right back into it. So we're starting with question 15, which is a solving systems of equations problem. If you look, it doesn't specify a method. I would suggest using substitution because I've already got what y is equal to, and it's going to be easy to substitute. So let's do that. So we're going to do that. We're going to replace the y with negative 8x plus 5. So I'm going to have 8x plus y, but instead of y, I'm going to write negative 8x plus 5, and that is equal to negative 7. Okay, so I have an 8x here and a negative 8x here. What's going to happen with those two sets of x's? Well, the 8x plus a negative 8x will cancel, and I'm going to be left with 5 equals 7, negative 7, which there's nothing I can do here, and this is not a true statement. So if this is not a true statement, then what that means is there is nothing I can plug in for x or y that would make these two statements true. And that means, in terms of a system, that means there's not an x and y that they both share. So these two lines are never going to intersect. So these are going to be two parallel lines, or I'm sorry, these are two parallel lines. So they'll never intersect. So there is no solution. Okay, and if you were to solve this and to get y by itself on the second equation, what you'll end up getting is y equals negative 8x minus 7. And what I want you to notice is the slope in both of these equations is exactly the same, and that would have indicated a set of parallel lines. The y-intercepts are different, which means they're two different lines, so they are going to be parallel. It's not two of the same line, so no solution. Okay, so number 16, same kind of concept. We have y solved for, and we're going to substitute in for y. And so this is going to be negative 2x minus y, but instead of y, I'm going to plug in negative 2x minus 6, and then I'm going to continue the second equation. So this is going to be minus 6 equals 0. Okay, so 2x, oh wait, let's get the parentheses taken care of first. Let's distribute this negative. So this will be negative 2x. Negative times a negative is a positive, so plus 2x. Negative times negative is a positive, so plus 6. Bring down this minus 6 equals 0. So then I'm going to combine my like terms. Well, negative 2x and positive 2x cancel each other out. 6 minus 6 is 0, so I end up with 0 equals 0, which is a true statement. But I don't have an x or a y, so what that means is no matter what I plug in for x and for y, my statement's going to always be true. So whatever ordered pairs I have, it's going to be a true statement. They share every single xy pair. So that means it's not that there's no solution, it's infinitely many solutions. I don't know why I wrote this one in print and this one in cursive. I just kind of felt like it today, I guess. So this one has infinitely many solutions. And I'm going to show you just like we did up top where we had the parallel lines. If I were to get y by itself, so let's say I added y to each side, what I would end up having is y equals negative 2x minus 6. Which if you look is the exact same thing that I had here. So it's two of the same lines. They're just written differently. So it's one line on top of itself. So it is a true statement. So it's infinitely many solutions. They share every single point. All right. So you can solve these out, or you can just kind of look at their slopes and y-intercepts. So if they have the same slope and different y-intercepts, no solution. If they have the same slope and the same y-intercept, it's infinitely many solutions. If they have different slopes, then they're going to have exactly one solution, which is what we're used to seeing. All right, so items 17 and 18. A salon's business manager provided the following models of growth, where X is the number of years the salon has been open and Y is the number of clients. The salon stylist can service no more than 3,800 clients collectively. So any more than that, and the salon can't keep servicing more than that many number of clients. Basically, there'd be too many clients for the salon to keep up with. They would be either like double booking people, or it'd be really long wait times, or they just don't have enough manpower to do it. So they'd have to expand their business, or just start turning clients away. So, which you don't want to do. I mean, expanding business is the, anyway, this is not a business class. So, all right, actually, I'm looking at these. One of these should be minimum and one of these should be maximum. So there's a typo on one of these, and we'll figure that out in a minute. So number 17 says, considering both projections of business, how many clients might the salon have after 7 years? So what we're going to want to do is we're going to want to find the equations for each of these models. So the first thing I'm going to do is I'm going to look at my rate of change. So we got to find the slope first. So if y'all don't remember, your slope is you take your y's and subtract them and divide them by, or you take your x's and subtract them and you divide. So if I subtract my y's, I have, we're just going to do the two easiest ones we can. 11,000 minus 500. So 11,000 minus 500 over 3 minus 1. We're going to go in the same order. And that's going to be 600 over 2. And so my slope, if I divide these, is going to be 300. And what that means is that we are going to be, with this business growth model, we'd be collecting 300 clients a year, or adding 300 clients a year. So my slope is 300. So if I write this in slope-intercept form, I have y equals 300x, plus I need to know how many clients I would start with at year 0. Well, if at year 1 I have 500 and I'm earning 300 clients a year, I could subtract and go back a year. 500 minus 300 would be 200. So I have 300x plus 200. Okay. If I look at this model, the one that is with my graph, I already have my y-intercept. My y-intercept is 200. So we'll have y equals something in front of x plus 200. So I need my slope. Well, I'm going to use the same formula. I'm going to subtract my y's and my x's. So I have 3,800 minus 200. So there's my y's on these 2 points. Over my x's are 9 minus 0. Which this is going to give me 3,600, not 360, divided by 9. And that should be a growth of 400. That should, if I divide that, that should be 400. So this is y equals 400x plus 200. Okay, so I've got my two equations, which isn't even what the question asked for, but we need those in order to answer the next couple of questions. Okay, so it says, considering both projections of business, how many clients might the salon have after 7 years? Give a written description and then write your answer as an inequality. So we want to know how many clients they would have after 7 years. So let's plug 7 into each equation. So this would be my minimum. This is my maximum. Let me write that out because I told you there was a typo, so this one's the maximum because this one's got a higher slope. Okay, sorry, it was bothering me. Okay, so we're going to plug 7 in for x because 7 is the number of years and y is the number of clients. So we're plugging into this equation. We're also plugging into this equation. Okay. So 300 times 7. So 3 times 7 is 21. And I'm just going to add my 2 zeros. Plus 200. So after 7 years, my minimum business growth projection. So at the slower growth rate, I'd have 2,300 clients. At the faster growth rate, 7 times 400 is 2,800 plus 200. That'd be 3,000. Okay, so it says give a written description. So we're going to write in words at 7 years. The salon should have between 2,300 and 3,000 clients. Okay, and then it also says write it as an inequality. So as an inequality, we're going to take our smaller number, 2,300. This is our y value, it's the number of clients. So 2,300 is less than or equal to y, which is less than or equal to our larger number, which is 3,000. So our number of clients should be somewhere between 2,300 and 3,000. Okay, and then 18, this is basically backwards. So this says the salon employs several stylists who can service no more than 3,800 clients collectively. Considering both projections, how long might it take for the salon to reach their maximum number? So again, we're just, instead of plugging in for X, we have the number of clients, not years. So we're going to plug this into Y. So we want to know at how many years will we hit our maximum number of clients that we can handle. So we're going to set this up. We're going to substitute 3,800 in for Y. We're going to leave X alone, and then we're going to solve for X. So let's start by, we want to get X by itself. Let's start by subtracting 200 from each side. 3,800 minus 200 is 3,600. So 3,600 equals 300X. You can divide by 300. And that should be X equals 12. So at our slow business rate, it should take 12 years. Let's look at this side. We're going to follow the same steps. We're going to subtract by 200. We'll get 3,600 equals 400X. We're going to divide both sides by 400. And then after I divide, I should get 9 equals X. So at my maximum business growth, at my fastest rate of growth, it'll take me 9 years to reach that number of clients. At my slowest rate, it should take me 12 years. So it should take me anywhere from 9 to 12 years. So written description is going to be, it should take between 9 and 12 years to reach the maximum number of clients, and we'll just put max number. And then as an inequality, because it asks for both, we'll have 9 is less than or equal to X is less than or equal to 12. Because X should be anywhere between 9 and 12 years. So 9 is less than or equal to X, which means X is, like the minimum is 9. X is less than or equal to 12, which means my maximum is 12, so X is in between there. All right, I'm going to leave this up for a second. I guess I don't have to. Y'all have a pause button. I'm tired. All right, so let's go ahead. I'll swap over to the next page. I keep forgetting that there's a pause button, so if I am going too fast, y'all can always pause and rewind. I keep them like, I don't know. Okay, so we are now into the constructed response section. So let's go ahead and get started. So these are going to be worth a little more points than your multiple choice because it is a little more detailed, and that's okay. So yeah, let's go ahead and get started. So Matt went to the store to buy coloring books. He purchased a total of 9 coloring books for $60. Oh my goodness. Sorry, as a mama of a toddler who goes through that's ridiculous. Okay, so he purchased a total of 9 coloring books for $60. No one ever said math problems made sense. It just, sorry, that personal life caught up with me. So animal coloring books cost $7.50. Landscape coloring books cost $6.25. These must be adult coloring books, like grown up, not the Crayola Paw Patrol coloring books that I have to get. Those are $1. Okay, sorry. All right, so define your variables and write a system of equations to determine how many of each type of coloring book Matt purchased, then solve. Finally, interpret your solution. Okay, so first things first, define your variables. Define them. You want to make sure that when you show a system or when you solve a system that you know what your X represents, you know what your Y represents. You don't want to mix them up. So he has 2 different kinds of coloring books. Animal coloring books, so we'll do A for the number of animal coloring books. We'll just put books. I'm not going to put coloring books. And then L is going to be the number of landscape coloring books. Okay. All right, so then we need to write our system. So we check off define your variables. If you don't define your variables on the test, we will mark off because I got to know. I don't know if X means animal or landscape, and I have to know which one you intended to go where. So I know that sounds hateful. No, actually it doesn't. Y'all are used to this. Y'all are used to us being nitpicky at this point. It's been 18 weeks, so. Okay. All right, so writing our system. So let's look at what we know. We know we have a total of 9 coloring books. Some of those are animal and some of those are landscape, but we don't know how many. So we're going to say the number of animal books, A, plus the number of landscape books, L. So A and L together should be, there's a total of 9. So A plus L should be the total 9. Okay, so let's look at what we know for the cost. So we know that the animal coloring books cost $7.50. So when we pay for this, it's going to be $7.50 times the number of animal coloring books. It's $7.50 for each one. Plus, it's $6.25 for the landscape one, so 6.25 L. And then that's going to end up giving us our total cost, which was $60. All right, so we've written our system. So define our variables, check. Write a system, check. And now we need to solve it to determine how many of each type of book you purchased. So you can do this a number of ways. You can go get you some graph paper and graph it. I wouldn't suggest it, but you could. I wouldn't do it though. You could use elimination. You would have to either multiply your top equation by negative 750 or by negative 625. However, Ms. Gallant just doesn't like dealing with decimals. So I think I'm just going to solve the top equation for either A or L and substitute. So let's get L by itself. Let's solve for L and we'll plug it in here. So if I solve for L, I have to subtract each side by A. And I'm going to get L equals 9 minus A. Okay, so I have what L equals. I'll plug it in here. And so now I have 750A plus 625L, but I'm not going to write L. L is 9 minus A, so we'll do 625 times 9 minus A. Hold on 1 second. Okay, so I'm plugging in 9 minus A for L, and equals 60. All right, so let's distribute let's distribute 625 to 9 in A. And when I do that, let's see, let me get my calculator out. Got a new calculator, I'm trying to figure it out. Okay, so we're doing 625 times 9, and that is 5625. So plus 56.25 minus 6.25a. That's going to be equal to 60. All right, so I'm going to combine my like terms. So I have 750 and 625 and negative 625. So when I combine those, 750 minus 625 is $1.25. So 1.25a plus 56.25 equals 60. I'm going to subtract the 56.25 from either side. And I get $1.25a equals, okay, I did it in my head, but I had to double check because I hate to tell y'all wrong. 375, all right, so 125a equals 375. Then I'm going to divide both sides by 125. And a should equal 3. Yeah, double checked it. Okay. So we have a equals 3. So I'm not done. I have a number of animal books, but I need the number of landscaping books. So I'm going to take this A and plug it into either the top or bottom equation. If you feel strongly about plugging into the bottom equation, go for it. I'm not doing that. I'm going to the baby equation at the top because it's a lot easier. But you know what? If you feel like it, go for it. All right, so instead of A, we're going to substitute it with 3. So we have 3 plus L equals 9. Okay. I'm just going to go ahead and say I'm sorry if this video seems choppy. I got interrupted with a student coming in, with a phone call, and with announcements in the time it took me to film this video. So I've been pausing and replaying and pausing and re-recording, and so if it's choppy, I'm sorry. Okay, so I have 3 plus L equals 9. We have to solve for L. So we're going to subtract 3 from either side. This cancels, and I get L equals 6. Okay, a lot of people would be done here, except we solved it, but it says interpret your solution within the context of the problem. So that means, what does A equals 3 and L equals 6 even mean? And for us, what that means is that Matt bought 6 landscape coloring books, and okay, so Matt bought 6 landscape coloring books and 3 animal coloring books. Okay, so Matt bought 6 landscape and 3 animal. All right, so let's look at number 20, and then we are done. So this video is a little bit longer than the other ones, but I did longer problems. So, okay, number 20. Ralph has $15 to spend on snacks at the movies. Candy costs $5 per package and drinks are $3 each. So, again, ridiculously expensive, but I'm not as shocked because it's a movie theater. So, that's why you sneak candy in your purse or your pockets. Probably shouldn't record that, but, you know, I don't do that. I'm a good person. Okay, before I get in trouble. All right, so Ralph has $15 to spend on snacks at movies. We've already been given the inequality. Yay! We've already got the inequality. So, all we have to do is graph the inequality, identify the x and y intercept, and explain what each intercept represents in the context of the problem. So, let's go ahead and we're going to graph. So, if you think about it, you're not going to buy negatives when it comes to movies or candy or snacks or Cokes or whatever it is. So when it comes to any of this, you're not going to purchase negatives. So we only need this quadrant. So, okay, so we're going to go ahead and label this. X is the packages of candy. So X we'll call the amount of candy. Okay, and then Y, so hope no one gets motion sickness because I'm turning the camera and the page. So this is going to be the number of drinks. Okay. And then we need to label our graph. So I think, so if we look at this, if I don't spend any money on candy, I could divide 15 by 3 and get 5. So I think the most of anything I could buy is 5. So let's skip 1 and go by ones. So skip 1, 1, skip 1, 2. So each box is worth a half, but we're going to skip 1 each time we just trying to space it out, make it a little bit nicer and neater to read. Okay, and we'll do the same going this way. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. All right, so okay, so when you go to graph this, there's a couple of different ways you could do this. You could, it's in standard form, so you could calculate the x-intercept, calculate the y-intercept, and then connect the lines. You could also put this in slope-intercept form. And actually with graphing and inequalities, sometimes it's easier to put in slope-intercept form. Again, there's a bunch of different ways you could do this. So let's put it in slope-intercept form, because I think that's the route most people are going to go. All right. So to get slope-intercept form, we want y by itself, so let's subtract 5x from each side. And we're going to have 15 minus 5x is greater than or equal to 3y. Okay, and then to get y by itself, we're going to divide everything by 3. And that's going to give me 5 minus 5/3 x is less than or equal to y. But remember, we kind of like y on the left, so let's swap y on the left. We'll do negative 5/3 x. We're going to try to keep in slope-intercept, plus 5. And remember, y is smaller than all of this stuff on the left, so when we flip it, we want to make sure y is still smaller. Okay. All right, so let's look at this. So we want to start with, start at 5 on the y-axis, and my slope is negative 5 over 3. So let's go down 5 units. So remember, every 2 units, every 2 boxes is worth 1 unit because we're going up by halves. So this is 1, 2, 3, 4, 5, and then I'm going over 1, 2, 3. And I'm just making sure that we're being careful about scaling, because this is scaled evenly and they're scaled the same, you can still just go down 5 boxes and over 3. But I just want you to be careful about scaling, because if this is scaled differently from this, you cannot go by that logic. You can here because it's scaled the same, but if it's not scaled the same, you can't go by that logic. So this would be directly in the middle of the two. Okay, handy dandy straight edge time. This is a equal to, so it'll be a solid line, not a dashed line. And y is less than, so we're going to shade below this line. So pretty shading. Okay. All right. If you wanted to go a different route with this, you could. I don't know if you remember how to get your x and y intercepts from your standard form, which would kind of help you with the second half of the equation. I mean, we graphed them, so we're good. But your x-intercept should be it's whatever is in front of x, so you have 15 divided by 5. So it'd be this number divided by whatever's in front of x. So 15 divided by 5, which would be 3. And if you look here, my x-intercept is 3. So, or, well, 3, 0, if we're going to be correct about it. And my y-intercept, you would do the same thing. You would take the 15 divided by the 3, and you should get 5. I fixed it. I fixed it. I said it correctly and didn't write it correctly. Okay. All right, so now we did graph it, so you already had it, and we can just double check that, but if we use our standard form equations, we should get it correct too. So same thing. All right, so it did say interpret or explain what each intercept means within the context of the problem. So my x-intercept is 3, 0. That means I'm buying 3 candy bars and no drinks, which is the only, if I buy 3 packages of candy, I don't have any money left over for drinks. So what that means here, my x-intercept is if I buy 3 packages of candy, we'll just put 3 candies. I'm not going to have a lot of room. If I buy 3 packages of candy or 3 candies, I have no money left for drinks. Or I'd buy 0. If I buy 0 drinks, I can buy 3 candies, something in that vein. So that 3 is the most number of packages of candy you can buy, but that requires you to not buy anything to drink. And your y is just going to be the opposite. And we could say if I buy no candy, I can buy up to 5 drinks. Again, there's a bunch of different ways you can word this, but mainly if you buy 0 of one, you can buy up to this number of the other, is how we're interpreting it. All right, so let me just double check. Graphing inequality, we did that. Identify the x and y intercept, we did that. Explain what it means, we did that. So yeah, 11 easy points right there. Okay, so this is by far the longest of the 3 videos, but it did finish everything up pretty nicely. Good luck in your studying, and I hope you all do extremely well on your unit test. Have a good evening.